Hi guys, good afternoon. So in the last session, we were going with the EIGRP, and the last part was about the EIGRP route filtering. So what is route filtering? It's a way to filter your EIGRP routes. So we saw three ways that we can use. We can use access list, prefix list, and route map. So access list and prefix list, both of them we have seen. Now the third method is using the route map. Using route map. So like I said, using with the help of route map, you can use both the things. Okay. With route map, we can use both access list and prefix list. Okay, like your access list and prefix list, they are working as a selector, right? So route map, we directly cannot make it as a selector. Route map cannot be used as a selector. Route map is only capable of defining an action. Okay. So what we'll do as a selector, we will use either prefix list or access list only. Okay. So what I'll say with route map, we can use both access list and prefix list. Okay. So first we will see with access list. Okay. So almost the commands are going to be the same only. The first thing we will do is going to define an ACL, then action we will define in the route map, and then we will attach the route map to the distribute list command. Okay. So number one, you will say create access list to select the network. So how do you create an access list? You'll say access list. You'll give a number between 1 to 99. Then you'll say permit. Then you'll say network ID. Okay. Then you'll say wildcard mask. Okay. Once your access list is done, then after you'll say create route map to define the action. You'll use route map to define the action. So you'll say route map, then name of route map. So first of all, we will take the deny action. Okay, and then you'll give a sequence number here. Okay, any sequence number 0 to 65535 you can give. Then after you will match the IP address. So you will say match IP address. And here you will give your ACL number. Once this is done, after that, you have to give one more route map statement to allow rest of the traffic. Like I said, doesn't matter it's your access list, prefix list, or route map. Everywhere we have the implicit deny. Okay. So you'll say route map, and then whatever the name of your route map, then you'll say permit and sequence number. You have to make sure that this sequence number here in the permit statement, it should be greater than this. It should not be same. Okay. So let me mention here itself, greater than deny statement. Okay. Sequence number greater than deny statement. So this is our deny statement. So this sequence number should be larger. Once this is done, then we will attach it with the distribute list command. Attach a route map to distribute list command. Okay, for filtering routes. Okay. So you'll say distribute list. Then this time, see, earlier what we were doing is when we were using prefix list, we were saying prefix. When we were using access list, directly we were giving the number. When you're using route map, you will say route map. Then you'll give the name of the route map. After that, you'll give the direction, whether inbound or outbound, inbound or outbound, and then you'll give the interface, that on which interface you want to filter. This is how the comments are going to be. Understood? Note it down, then we'll do the practical. Got it? Route. Start all the requests. Meanwhile, the routers are coming up. So let's also see the prefix list. There won't be a very big change. First of all, we'll create a prefix list. Okay, but instead of deny, we will say permit. Okay, so okay. So first thing we will do, create prefix list to select the network or select the route, not the network. Okay, which route you don't want to allow. Now, the creation of prefix list is simple, same like route map, IP prefix list. Okay, same like we say route map name. Here we will say prefix list name. Then we define the action, right? Okay. So we'll say here IP prefix list, then the name of prefix list. Then you like say permit, network ID, then CIDR. After that, just create the route map. Create route map to define the action. So we'll say route map, name of route map, permit. Sorry, this one we want to deny. Then we'll give a sequence number. Then we'll say match IP address, prefix list, and then name of prefix list. Then you'll say route map, name of route map, permit, and again this sequence number will be greater than permit statement. Then just attach this route map to the distribute list command. Sorry, deny.
Deny statements.
Yes, deny. Sorry. Attach the route map to the distribute list command. We will say distribute list route map name, direction, and then interface. And this command will be in the EIGRP. Okay, don't try directly. Don't try this one directly in the global configuration mode. Totally different concept. Why variance is used? You want that, okay, two unequal metric routes, they should enter into the routing table. That is variance. That means you want your physical successors in the routing table. That is for that reason you use variance. Leak map, you have a summary, and from the summary you want to advertise a specific route. That is a leak map. Okay. Okay. This is clear. Now let's go to the lab. Note it, everyone. Today we'll wind up around 3 only. I have a meeting. Clear? Okay. So now let's take access of the routers. This configuration we already have in the notepad. So R1 configuration. Okay. Here we have one adjacency, two here, and all good. So let's check the routes on the R3. If I say to show IP route EIGRP, so as of now I see all the routes. Now we are going to filter using the route map. Okay. So let's go on R2. Anywhere you can configure on R1 also, R2 also, R3 also. On R1 you will configure in outbound direction. On R2 we can configure inbound also, outbound also. And on R3 we will configure only in the inbound direction. R3. Okay. So anywhere you can configure. Now let's say again I'll be configuring on R2 only. So first of all, let's try using the access list. And let's say on R3, as of now, I have all the routes. I don't want to see the route number 3.0. So I'll say access icon list 1, deny, and let's say 172.16 3.0 00025. Done. First step. Second step, create route map. Oh yes, right. Correct. It should be permit because action will be defined in the route map. So we'll say route map, name, call it R map, deny, let's say sequence number. So sequence number, like I said, anything between 0 to 65535. I'm giving here 10. I'll say match IP address. And what is my ACL number? 1. sequence number 20. Done. Router EIGRP1. Then we'll see distribute list. Okay, again. Yes, you're right. This will be combination. Oh no. Router EIGRP1. Okay, let me show you the route map configuration. We'll show run pipe section. Okay. Router EIGRP1. Distribute list. Route map. RMap. Direction is outbound through which interface? 0/1. Now let's see graceful restart of the neighbor. So right now we have, you can see, I have 3.0. Graceful restart. We don't have 3.0. Clear? Okay. Now, no route map, RMap, and also route EIGRP1. Say no to this command. No. Done. All the configurations removed. So we should have 3.0 again. Okay. Now let's say what I want to do is this time I don't want 0.0 and 1.0. Okay. Understood the scenario? 0.0 and 1.0. Or let's say I don't want 0 and 2. I just need 1 and 3. Let's see if you can come up with something. My requirement is I don't want 0 and 2. I want 1 and 3. And I want to use prefix list. So tell me the comments. Requirement is 0 and 2 should not be there. Okay. And 1 and 3 should be there. So what will be my comments? How should I create the prefix list? IP prefix list, name, that's a T list, then permit. Now, network ID, what will be my network ID? So how should I give it? If I would give 0 and 1, you would say 0, 0 and CIDR, you would reduce by 1. You would make it /23. And that would work. That's why I said 0 and 2. So what should I do now? Okay. That is the answer. Specify more than one statement. Same like ACL, you can create multiple entries. This is also prefix list. In a list, you can have multiple entries, right? So what you'll say, 172.16, 0.0 /24, and you will say 2.0 /24. Check, do show run, pipe section, prefix list. Then same like that, you create the route map. Route map, RMap, deny, 10, match IP address, prefix list, and name is what? A-list. Okay. Then after, we have to say permit 20. Route to EIGRP 1. Distribute list, route map, R map, direction is outbound, interfaces is by 1. Now, right now, I'll have all the routes. Once graceful restart. Now let's check. And check. Understood? So this is how you can do it. No, which one? Line by line. Same like access list, line by line, the rules will be matched. So first this rule will match, which will say that, okay, we want to deny this. And the second statement, I haven't specified anything. That means everything allowed because I have given a permit statement. Okay. No IP prefix list, list, no route map format. Okay. This is clear. Now next task is online people clear, right?
Yes, sir.
Now next thing is EIGRP name mode. Stuff will also come, don't worry. I'm not forgetting everything. I remember what all the topics we have to cover. Now you guys check from which mode the EIGRP named mode, from which version named mode was introduced. I'll be back in a minute. 15.x. Okay, so the name mode you can say was introduced after Cisco IUS version 15.1. Okay. Now, what is the benefit of this? Like in the previous mode, that is classic mode, what is happening? That there are few things we are configuring in the EIGRP configuration, and when you want to configure summary and all, then you have to go to the interface. Summary we were going and configuring on the interfaces. So this named mode combines everything. That means all the configuration will be within the EIGRP configuration only global configuration. Okay. So here everything is configured globally. Okay. So you will say we don't have interspace specific configuration now. Everything is configured globally. Here. And your classic mode supports IPv4, but named mode support both V4 also, V6 also. Okay. Supports both address families, IPv4 and IPv6. This is clear. Now, oh, here EIGRP named mode configuration was released to overcome some of the difficulties network engineers they were having with the classic EIGRP autonomous system configuration, including scattered configuration and unclear scope of command. Some of the commands you executed on the interfaces, some of the commands you executed inside the EIGRP configuration. So it was completely scattered configuration. So there are some of the benefits of using EIGRP named mode. One is all configuration occurs in one location only. Second one, it supports current EIGRP features and even future developments. It supports multiple address families like your VRF. Okay. Then named mode is also known as multi-address family configuration. That means IPv4, V6, VRF, everything it supports. And also commands are clear in terms of scope of their configuration. These are some of the benefits. Note this down. VRF will tell you. VRF. Like in switch you have VLAN. You divide a switch into multiple switches. Same like that in router we have VRF. You divide a single router into multiple routers. A router will have more than one routing table. As it says, virtual routing and forwarding. Okay. Done. Okay. So your named mode EIGRP configuration is divided into 3 sections. Okay. EIGRP named mode configurations are divided into 3 subsections. Okay. Number 1 is the address family, where we select, whether you want to use IPv4, v6, like this. Number 2, we have the interface configuration. That means any interface specific configuration is there. That will be done in the interface part. And number 3, topology. That means kind of you can say any global configuration is there. Okay. Now we will see basic configuration. Okay, so first of all, I'll show you in the routers, then we will type it here. Okay. So let's go here. Now, right now we are using classic EIGRP, right? Right now we are using classic EIGRP. Let's go and say no router EIGRP 1. And here also, do we have any configuration? I think distribute list is there. No distribute list, no prefix list. Okay, everything is removed. So I'll say no router EIGRP 1. And here also, done. If I check on R3 right now, do show IP route EIGRP, nothing. Now let's configure. So earlier we were saying what? Router, EIGRP, then ASN, but this time, sorry, instead of ASN, we will use a name. So let's say I'll give it a CNP. Here I have a command address family. I have a command address family, and I can select from here whether I want to go with the IPv4 or v6. Okay. So let's say as of now, IPv4. Okay. Then after, if you see, I have an option to define an AS number here. Right now, I'm not using VRF. I'm not using multicast. We will go with the AS number. So AS number is what? Let's say 1. So autonomous system 1. This is clear. Okay. Now here we can give the network statements. In this part, we can give the network statements. We have an option. You can see. We have an option. This is clear. So let's say if I want to define network. Okay, so I'll say network and whatever the network 172.16.0.0. Okay. Then wildcard bits. So 00 and let's say 3.2. Then and I'll say network 192.168.12.0. Then networks are given. Similar commands I'll say here. Router, EIGRP CCNP, address family IPv4, autonomous system number 1, network 12.0. And you can see my neighborship is coming up 23.0. Same thing here. Router EIGRP, CCNP, address family, IPv4, autonomous system number 1, And then I can say network 23.0. Then do show IP route EIGRP. Same routes we have. Now, like I said, any other configuration. So we have one command here, AF interface, address family interface. So that means any interface specific configuration you want to do. So let's say my address family interface is gig0/0. Okay. Then see here what all the commands you can execute. You can configure the summary also. You can configure split horizon, passive interface. These kind of commands, you want to change the hello interval, hold time. So all these commands we can do here. This is clear. That means any interface specific configuration. Any interface specific configuration can be done inside the address family interface. This is the command. And if you don't want to do it, exit AF interface, and I can use the command topology base. Okay. If I hit enter, now check. Here I can configure variants. I can configure timers. I can configure how many maximum path in the load balancing I want to use. I want to configure distribute list. That means route filtering I can perform here. So all those things can be done here. Understood? So that means any global configuration you want to do, that will be done in the topology base. Any interface specific configuration you want to do, that will be done in the AF interface. If you want to define networks, those things will be done in the address family. Understood? There is no other change. Clear? Okay. Online people clear?
Yes, sir.
So if we talk about basic configuration, EIGRP link mode, basic configuration. So you'll say router EIGRP. You're going to give a name here. Then you will say address family, whether you want to use IPv4 or IPv6, autonomous system, and you'll give the ASM. Then you can give network ID, and wildcard. Okay, and two commands, like I said, those are extra. Topology base, if you want to do any topology related configuration. And if you want to do AF, interface specific configuration, for that AF interface need. Here, this is how you'll do the configuration. Understood? Basic configuration is clear. Okay. Now, along with this, let's go with one more small concept, that is the HMAC SHA authentication. Now, earlier we saw that classic EIGRP mode supports only MD5, right? So this is named EIGRP mode, and it supports both. It supports the HMAC SHA also. Okay. So you can configure it with the keychain like we configured MD5, or you can configure it without keychain also. Okay. So see, HMAC SHA 256. First of all, it is more secure compared to MD5. Second thing, this authentication can be configured with keychain or without keychain. Both the possibilities we have. Okay, understood? Now, the simplest way to configure this type of authentication is use a router, EIGRP, and name. Then you'll give the address family. Address family, let's say IPv4 or v6, whatever. Autonomous system, then ASN. Then you will use the command AF interface and interface name, because authentication is interface specific on through which interface you want to have authentication. So directly you will give the command authentication mode HMAC SHA 256, and then directly you'll give the password. That's it. Only one command is there extra. So in your basic configuration, only one extra command is there, and your HMAC SHA authentication is configured. Clear? Named only. In the classic, it doesn't support. In the classic, we saw only MD5. This is clear. Now let's go and configure it. So we already have named the EIGRP configured. Only one extra command I'll configure. After studying entire EIGRP, you're asking me why I'm giving ASN. Why? Tell me. Tell me why. Yeah, if you know, then tell me. Simple. EIGRP is a IGP protocol, provides communication within the same years. So you have to define which autonomous system you are using, and it has to be same on all the routers. That's okay. Okay, so let's go here. So what I'll do here, let's say this is R1. I'll say AF interface, and interface is gig0/0. I'll say authentication mode, and you can see I support both MD5 as well as HMAC SHA. So this time we will go with HMAC SHA 256, and directly now I can give the password. Okay, so let's say I'll give the password as sysphone. Done. Now it should break neighborship. Neighborship break. Why? Because authentication HMAC SHA configured. And this side, you can see what is the reason. Authentication failure. So this side also, if I will go to AF interface and Z0/0, because this side I have Z0/0 interface. Between R1 and R2, I have only Z0/0 interfaces. Then I can say authentication mode HMAC SHA 256, password is sysphone. Now authentication will match and they will communicate. Neighborship will come up. This is your neighborship out. How HMAC? Because this is a complex algorithm and it has a larger, you can say, message digest size. That means the hash value size is larger than MD5. And also its algorithm is a bit complex. You see hello. Inside the hello message, you can take a look. This is the authentication SHA 256. This is the message digest. Okay. Clear? So any doubt? No, then today we'll wind up. Okay. So now we have only the stub part and we have SIA query and reply. 2 topics are remaining. Those we will complete in next session and we'll start over screen. Okay. This time I guess I'll need some extra sessions. We'll see. Okay, guys, then I'll see you tomorrow. Have a good day.